Imagine a burning car, a trapped passenger, a bystander rushes forward, adrenaline surges. With superhuman strength they lift the car. Impossible? Not entirely. Our bodies hold hidden reserves of power unleashed in moments of crisis. This remarkable ability isn't a Hollywood invention, it's rooted in the very physiology we all share. Our muscles are capable of far greater feats than we typically demand of them. But this potential is usually kept in check, a safety mechanism to prevent self-harm. However, under extreme circumstances, the brain overrides these limitations, flooding the body with hormones like adrenaline. This chemical cocktail triggers a cascade of physiological changes, transforming us, however fleetingly, into real-life superheroes. But how does this transformation occur? To understand, we must delve into the fascinating world of human biology and the science behind adrenaline. Adrenaline, also known as epinephrine, is a powerful hormone produced by the adrenal glands. In response to danger, it floods the bloodstream. Heart rate and respiration increase, delivering oxygen and fuel to muscles with incredible speed. Blood sugar levels spike, providing readily available energy for explosive movements. But adrenaline's effects extend beyond these immediate physiological changes. It sharpens focus, heightening our senses and awareness. Pain perception diminishes, allowing us to push past our perceived limits. This primal survival mechanism is hardwired into our DNA, a legacy of our ancestors who faced life-or-death situations daily. In essence, adrenaline unlocks our evolutionary inheritance, granting us temporary access to extraordinary strength and resilience, but this access comes at a cost. The sheer intensity of this experience takes a toll on the body, often leaving us shaken and exhausted in its wake. This begs the question, if we possess such latent power, why don't we have constant access to it? The answer lies in a fascinating phenomenon known as neural inhibition. Our brains, while incredibly complex, are also remarkably cautious. They constantly monitor and regulate muscle activity, preventing us from exceeding safe limits. This phenomenon, known as neural inhibition, acts like a brake system, ensuring we don't tear tendons or break bones under normal circumstances. Think of it like this: our muscles are like powerful engines capable of generating immense force. Neural inhibition acts as the governor, limiting the engine's output to prevent damage. However, in emergencies, the brain temporarily overrides this governor, allowing us to tap into a greater percentage of our muscle fibers. This explains why untrained individuals can perform seemingly impossible feats of strength in life-or-death situations. Their brains, flooded with adrenaline, temporarily disengage the safety protocols, unleashing the full potential of their muscles. But even in these extreme circumstances, there are limits to what we can achieve. The physics of superhuman feats beyond brute force. While adrenaline plays a crucial role in unlocking superhuman strength, the laws of physics still apply. Our bodies are bound by the limits of bone density, muscle mass, and leverage. Lifting a car, for instance, requires more than just raw strength. It involves strategic positioning, leverage, and a bit of physics on your side. Consider the act of lifting a heavy object with a lever. By increasing the distance over which force is applied, we can amplify our strength and move objects far beyond our unassisted capabilities. Similarly, understanding the principles of momentum and force distribution can allow us to perform feats that seem to defy gravity. While we might not all become real-life superheroes, understanding these principles allows us to appreciate the remarkable capabilities of the human body and the delicate balance between strength, safety, and the laws of physics. The final frontier, pushing the boundaries of human potential. So could we ever access these hidden reserves of strength at will? Could we train our minds and bodies to tap into this superhuman potential without the need for life-or-death scenarios? This question has captivated scientists and philosophers for centuries, and the answer remains elusive. Advances in neuroscience and biomechanics are constantly pushing the boundaries of human potential. Researchers are exploring techniques to enhance muscle activation, improve neuromuscular control, and even develop exoskeletons that augment our strength and endurance. While the idea of unlocking our full superhuman potential remains a tantalizing possibility, it also raises ethical and philosophical questions. What would it mean for humanity if we could all access such power? Would we use it for good, or would it amplify our flaws? These are questions we must grapple with as we continue to explore the final frontier of human potential. Don't miss out on more fascinating insights into human potential. Subscribe to our channel and hit the bell icon to stay updated.